Okay, let's talk about polynomial inequalities. Our objective, solve polynomial inequalities, both graphically and algebraically. All right, as usual, let's talk about what we know that's going to be applicable for this video lecture. Well, we know first what a polynomial function is. A polynomial function in one variable, that is. It's a function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus etc., etc., etc. Again, decreasing exponents, decreasing whole number exponents plus a sub 1 x to the first, and then finally the constant plus a sub 0. And let's also recall, number 2, what an inequality is. An inequality is a statement involving two expressions separated by one of the following, or one of the inequality symbols: less than or equal to, greater than or equal to. Okay, so let's talk about we'll first talk about how to do this graphically, and then we'll talk about how to do this algebraically. Graphically is probably the easier of the two methods. So first things first, I've put some steps here. First things, number 1, rearrange the inequality so that 0 is on the right side. So that's going to look like f of x is less than 0, or f of x is less than or equal to 0, or f of x is greater than 0, or f of x is greater than or equal to 0. You do this if necessary. If the 0 is already on the right side, then you can skip this step. Step 2, okay, graph it and locate the zeros, your x-intercepts, with your graphing calculator. Step 3, between your zeros, the function, the graph, and recall that a polynomial function has a smooth and continuous graph. Between the zeros, the function is either above the x-axis, in other words, the function is greater than 0, or below the x-axis, in other words, the function is less than 0. Okay, so that'll tell you what to do in terms of what's a greater than or less than, and you include the zeros, step 4, if you're dealing with an inequality that has an equal sign also included. So if you're dealing with less than or equal to 0 or greater than or equal to 0, we want to include the zeros in our solution. So let's do some examples. We'll do one example graphically. We'll look at the other two examples graphically as well. Okay, example 1, here we go. Solve this, I'll jot it down here. X to the 4th greater than or equal to x. Solve graphically. Okay, first thing we got to do, okay, we have to write this. So we're going to have x to the 4th minus x greater than or equal to 0. Okay, we want to rewrite it so we have a 0 on the right side. Okay, so let's see here. 0 on the right. Okay, so we've rearranged it so 0's on the right. So now, graph the function f of x is equal to x to the 4th minus x. Let's graph it. Okay, so I'm going to come into my graphing calculator. I think you can see that okay. I don't know what's in here. That's in here. Let's get rid of that. Okay, x to the 4th minus x. And I'll go to my standard window to start myself off. And here comes the graph. Okay. Looks like I've got a couple of zeros in here. Let's zoom in and see what's going on here. So I'm going to zoom in. I need to zoom in on my x's. And I'll zoom in my y's too. The x is where I got to zoom in. Let's go to zoom. Let's zoom in and see what happens. That works pretty well. Okay, well you can clearly see here, where are the zeros? Well, it looks like they're both, well here you go, here's one. It's already telling me because I've got it zoomed in, but you can also do a second calc, 0, and we'll look here. Now that looks like the origin to me, but we'll do a confirmation by doing a left and right bounds around it. Okay, so 1 0 is at 0 right here. My other 0 appears to be at positive 1. Well, we'll do a confirmation and calculate that 0. Let's put bounds around it. And sure enough, my other 0 is at 1. Okay, so I graph it, okay, from the graph. I have zeros at 0 and 1. Okay? Now let's take a look here. We're looking for this graph to be greater than, we want to be above or equal to, of course. We want to be above the x-axis. Okay, so here we are. So this graph is above the x-axis before 0. Okay? So when the graph is greater than 0, before 0, and after 1. Okay, graph is greater than 0, and that's our focus here, the greater than. We want to know when it's above the x-axis, before 0, so before the 0, and after 1. Okay? So that tells me the solution is negative infinity to 0, but we want to include the 0 because we have an equal sign here. So we want to go like this, okay, union, and we start at 1, and it's all the way to positive infinity, so before 0 and after 1, but we want to include the 1 again because we have the equal sign. So this right here tells us those two symbols, we want to include the zeros, okay, because we have greater than or equal to. Okay, we have greater than or equal to, so you want to include those zeros. Okay, so that's how you solve it graphically. Set it equal to 0, look at your graph, find your zeros, see where things are above and below, see where the graph is above or below between those zeros, depending upon the function, and then write it. In this case, I think I used interval notation. Okay, algebraically, a little more difficult. Okay, it's not overwhelming, but certainly more difficult than just looking at the graph. Okay, same idea. As necessary, we're going to begin with the same concept. We want to rearrange the inequality so that 0 is on the right side. Step 2, we're going to find the zeros. We're going to find our x-intercepts by solving f of x equals 0. Now, of course, we did this with our graphing calculator by just looking at there and doing calc zeros. We got to solve it here algebraically. Notice this might include some factoring. This might include using the quadratic formula, etc. Okay? Step 3, we're going to use these zeros to divide the real number line into intervals. And you'll see a couple of examples of this. Step 4, we then have to select a number within each interval and evaluate the function at that number to see if the function is positive or negative over the interval, if the graph is above or below the x-axis. Remember, we don't have the graph here, so we have to test a number within each interval. And then step 5 is similar. Include the zeros if you're dealing also with this equals 0, such as less than or equal to 0 or greater than or equal to 0. Okay, so some more paper. A little bit more work here. Here's my example number 2. Okay, So, solve, I'm going to put down here solve it algebraically. I forgot the algebraically part. We'll also look at the graph. We want to solve this algebraically. We don't have a graph. Okay, 2x cubed. When is 2x cubed a third degree polynomial greater than negative x squared, the second degree polynomial? Okay, first things first, let's rearrange it so that we have a 0 on the right side. So I'm going to add 8x squared to both sides. And now we have 0 on the right. Terrific. Okay? So now, let's recognize, that our f of x is equal to 2x cubed plus 8x squared. We want this to be greater than 0. Okay? So solve. Solve 2x cubed plus 8x squared equals 0 to find our zeros. Okay, when is f of x equal to 0? So solve this. Okay, as I mentioned, this, you want to be thinking about factoring, maybe the quadratic formula. How do you break this apart so we can use that 0 multiplication property? Okay, well, first off, can we do some factoring? Well, both of these terms have a common factor of 2 as a coefficient, and both of these terms have a common factor of x squared. I'm going to factor that out, and I'm left with x plus 4. Okay? And now I can see, this times this times this. Well, when is this 0? Well, so we have zeros at x equals 0. In fact, when x is 0, 0 squared is 0. And again, 0 times anything is 0. And when x is equal to negative 4. When negative 4 is 0, this factor is 0. And again, 0 times anything is 0. So here are my zeros. I have zeros at 0 and negative 4. I have x-intercepts at 0 and negative 4. Okay, so step 3, let's use these zeros to divide the real number line. Okay, so I'm going to make a number line. And I'm going to put negative 4 here, and I'm going to put 0 here to divide the number line into intervals. Okay, so my intervals. So I'm basically setting up a chart here. This interval right here, this interval goes from negative infinity to negative 4. Now notice that we're not including the zeros. We only have a greater than sign here and here. So since the negative 4 is not being included, I'm going to go like that. The second interval goes from negative 4 to 0. Again, notice we're not including the zeros because we don't have the equal sign with our inequality. So I use parentheses around the interval from negative 4 to 0. And our final interval goes from 0 to positive infinity. So these are the 3 intervals we need to test. Okay, we need a test number inside each interval. Well, less than negative 4, I'll pick negative 5. Between negative 4 and 0, I'll pick negative 1. Greater than 0, I'll pick 1. You just have to pick a number that is within the interval. It'll stand for all the numbers in the interval. Now we're going to do an f. We're going to evaluate the function at the test number to see if it's positive or negative. So negative 5 goes into our function. Oh my goodness, I need to do some calculations here. Okay, so let's see here. Whoops, let's quit out of here. Negative 5 is my first test number. So I want to test f of negative 5, and I want to see what comes out. Is it positive or negative between negative infinity and negative 4? Okay, here's my function. Let's see if it's positive or negative. 2 times negative 5, that cubed, plus 8 times negative 5 squared. I got negative 50. Okay, so I put negative 5 in as my test number, and the value comes out as negative 50. Okay, so the next row is going to be my conclusion. Well, in this interval, it's a negative. The graph will be below the x-axis. Let's look in this interval. My test number is negative 1. Let's put negative 1 into the function. I can probably do this one mentally. Negative 1 cubed is negative 1, so this is negative 2 plus 8. Okay, this is 6. So the conclusion in this interval is that the graph is above the x-axis because it's positive. Now let's test the point 1, f of 1, again mentally. 2 plus 8, I get 10. So this is also positive. Okay? So we want, according to right here, we want 2x cubed plus 8x squared to be greater than 0. Right here, we want it positive. Okay, this is what we're looking for right here. We want this to be true. So, when is it positive? Okay, the solution is, well, it's positive. It's positive in the interval between negative 4 and 0. Because it's negative. This interval, it's negative. That's not going to work for us. This interval is positive. Union, it's also positive in this interval. So we'll union that one, and we recognize, whoops, my inequalities, my infinity sign's not very good. I'll make it with a couple of zeros like that. Okay, so we know that it's positive, but we also, it's positive from negative 4 and greater, but we also know we can't include 0 because our zeros are not included here. So we're unioning. We can't include equals 0. So from negative 4 to 0, and then from 0 to infinity, don't include the 0 because this is not an equals inequality. Okay, let's graph it and see how we did. Okay, so again, here's our function. We want to put this in f of x. So y equals, let's clear this one out, 2x cubed plus 8x squared. And I'm going to do zoom standard again. And here comes the function. Whoa, okay. And you can see, where is it positive? Okay, well, where's it positive? Well, right here I'm betting is negative 4. Let's do a quick calc. That's 0. And let's take a look at this 0 that's over here to the left. Whoops, I just went right past it. Set some bounds around it, take a guess. Okay, so this graph, starting at negative 4, is all above the x-axis, except we're not including when it's on the x-axis. We're not including when it's equal to 0. So from negative 4 all the way to the left, it's above, except for the 0 right there. And again, we can't include the negative 4 either. So from negative 4 to 0, it's above the x-axis. And from 0 to positive infinity, it's also above the x-axis. Obviously, as you can see, graphically is a lot easier than algebraically. Okay, let's do one more algebraic example. A little more difficult. Not too bad, though. I think we're going to pull the quadratic. No, we're not, actually. We're going to factor a quadratic in this one. Okay, so solve. This is a degree 3 polynomial. X cubed minus 2x squared minus 3x less than or equal to 0 algebraically. Step 1 is done. It's already set equal to 0, so we're fine. Okay, and while we're here, let's recognize that our function is going to be x cubed minus 2x squared minus 3x. That's our function. When is this function less than or equal to 0? Okay, so we need to solve x cubed minus 2x squared minus 3x equals 0 to find our zeros. Well, this one, fortunately, because we can see we have a common factor of x in all three terms. So again, we'll just use some factoring first. X squared minus 2x minus 3. Okay, well, this is pretty nice. I know when x is 0, things are 0. So 0 is a 0 or a root. This is a quadratic. It turns out it's factorable. It factors as x minus 3 times x plus 1 equals 0. Well, now I'm totally factored. Okay, so I have zeros at 0, negative 1, and positive 3. These are also my x-intercepts. Okay, same thing. These are my zeros, these are my x-intercepts when they're real zeros. Okay, so I know my zeros, so we need to make a number line that divides into 4 regions. Okay, let's see here. Let's make a number line. Okay, so I'm going to put a negative 1 here, I'll put a 0 here, and I'll put a 3 here. So I have 4 regions to look at. Okay, so let's look at my intervals. Intervals, excuse me. The first interval is from negative infinity up to negative 1. Now notice I'm going to close the bracket with this interval because we are including the zeros because this says less than or equal to. We're including the zeros here. My next interval goes from negative 1 to 0. And again, close brackets because we're including the zeros. My next interval goes from 0 to 3. And my fourth interval goes from 3 to positive infinity. Okay, let's find a test number within each of these intervals. I'll choose negative 2. I'll choose negative 1/2. I'll choose 1, and I'll choose 4. You notice I either just kind of go 1 away or split the difference. If I have a choice to choose 0, I always do. And if I have a choice to choose 1, I always do. Otherwise, it doesn't make too much difference. Okay, what is the function's value at the test number? And what is the conclusion? Is it positive or negative? Okay, well, f at negative 2. We got to put negative 2 into here. This is negative 8. Minus 4 is negative 12. Let's see here. Negative 8. Minus 8, negative 16. Yes, this is negative. This is negative 8 minus 8 plus 6. It's negative 10. Out comes negative 10. So in this interval, it's negative. Okay. Let's take a look at this interval. Let's put negative 1/2 into the function. I'm going to need a calculator for that one. I can't do my halves very well. Okay, so we're going to do 0.5 to the 3rd power. Again, I'm going to put my half into my function. Minus 2 times 0.5 squared minus 3 times 0.5. And I got a negative number out, negative 1.875. Oops, I'm missing 0.5. I see a 0.5. Oh, I threw negative 0.5, excuse me. Look, I was wondering what was going on. This is negative 0.5. I totally made a mistake there. Again, I'll bet you saw that. Now let's go back and try this again. So negative 0.5 cubed. I was wondering why it didn't match up with my answer sheet. 2 times negative 0.5 squared minus 3 times negative 0.5, and out comes a positive 0.875. So f of negative 1/2 is 0.875, and that is positive. Okay, let's do f of 1. This one probably can be done mentally pretty quickly. 1 minus 2 minus 3, how about negative 4? This is a negative conclusion for this interval. The graph is below the x-axis. How about for 4? F of 4, 4 cubed, I don't know, so that's 64, minus 32, minus 12. You get 20. And that, of course, is positive. Okay, so we have our conclusions with our intervals. Okay, we want for this, right? We want this to be greater than 0. It says it right up here. We want x cubed minus 2x squared minus 3x to be less than or equal to 0. I might have misspoken. We want it to be less than or equal to 0. When is it negative? So we're looking for negative. We know that we covered the equals with our brackets. Negative. Well, how about from? Okay, so solution is, well, it's negative from negative infinity to negative 1, bracket, because we're going to take equal, we're going to include the roots, union, it's negative from 0 to 3, and again, we're going to include the zeros, so we're going to put brackets around that. And there's your algebraic solution right there. Okay, let's graph it and see if we're correct. So again, I'm right up here at the top. I'm going to graph that. Y equals, let's clear this one out of here. It's a third degree, x to the third, minus 2x squared, minus 3x. Okay, let's go to zoom. I'll do my standard window again. And there you go. Okay, so when is it less than or equal to 0? Well, it's less than 0 before it hits negative 1, which we have right here. Okay, right here. If you look at the graph, it's below the x-axis until it hits negative 1. Then it's on the x-axis. It's again below the x-axis from 0 to 3. Those are the two times it is below the x-axis, which means it is negative, as seen right here. So there's our solution set written algebraically. Okay, next up, let's take a look at how to do the same thing with rational functions.